And welcome everybody to the Daily Space Weather. We're looking at the sun here from the Solar Dynamics Observatory in 131 angstroms, ionized iron. And there is a C-class solar flare included in this data set. It comes from this area right here, that's why we're zoomed in. And there was a small radio burst associated with that too. It was only about 2 seconds in duration, and we don't see a coronal mass ejection from that. Actually, it's a pretty decent sized flare. It's almost an M-class flare there in the C range. We'll talk more about it momentarily. Also about extreme ionosphere anomalies. The total electron content showing up in the news, and a Quake watch. Here's the closest star in 304 angstroms, ionized helium. And we'll take a close-up of that area as well in this wavelength, which is great at showing plasma filaments. Some fantastic imagery there from the SDO. And it looks like we're going to be down to only 2 sunspot groups by the end of the day today. Sunspots are looking pretty weak. And here's the colorized magnetogram. You'll be able to see some of the degradation here. And we'll zoom out to 67% there. And you can see the time and date stamps there in the lower left. A little bit of a downtick here in solar activity. And it looks like full moon is today. Did you sleep well last night? It was pretty cloudy here, I think. Anyway, here's where stuff is now in the solar system. And there's where things will be in a week as Mercury swings around to the far side of the sun. The radio flux has dropped down to 87 solar flux units. And here is that data set in context. The black line here is the radio flux. The red line below it is the sunspot number. And for you new viewers, congratulations on realizing our channel exists. The radio flux is the most proportional data set we have to the sunspot number. In other words, it's a proxy of solar activity. Space Weather Enthusiast dashboard not showing us any NOAA warnings or watches for space weather events like geomagnetism. Calm conditions forecasted through the weekend. And I would put everybody on earthquake watch here as we're seeing some 6+ magnitude quakes kicking off. Perhaps those are foreshocks to a 7 magnitude quake. Significant uptick here in seismicity in the past 3 days. So there's the 90-day chart from volcanodiscovery.com. And you can see only one 7 magnitude quake here over the past 90 days. It's an earthquake drought. Largest quake of the past 24 was this 6.6 just south of Manila, Philippines. And you can see that is a quite significant earthquake there. Would have been felt in Manila. And there are no tsunami warnings, watches, or advisories associated with that. That quake happened at 8:48 p.m. Universal Time yesterday on July 23rd. So let's just check the list here, see what else is interesting on the earthquake list. Not that much going on. So I would remind our viewers, if you're in an earthquake-prone zone, please have a plan to be an asset, not a liability in the event of a disaster. There was also a 5.8 aftershock. Only about 12 minutes after that, about 9 minutes rather, after that initial quake, the 6.7 magnitude quake there at the Philippines, followed by a 5.8. There was also a 5.5 at Tonga. That's one of the largest quakes of the past 24. Vanuatu saw a deep quake. That was a 4.7 at over 600 kilometers estimated depth. Fiji also saw a deep quake at over 570 kilometers depth and at 4.6 magnitude. Some earthquakes continue in Southern California and the Nevada border area. Let's look at volcanoes next. Fagradalsfjall now showing up on the list here. Fagradalsfjall looks like it's having a little bit of a lull in its activity here. The lava area increase has sort of leveled off here. The lava discharge has leveled off. In fact, it's gone down. And the gas release has flatlined here, possibly an indication that the most recent eruption, which was fascinating, by the way, it featured a cinder cone volcano transforming itself into a shield volcano. Yes, it was absolutely fantastic. Never would have expected to see that happen, although it was kind of forecasted as soon as the eruption started to happen. The historic eruption of the Icelandic volcano Fagradalsfjall. And shout out to Kurt Begemann. We hope you do well in your gravel race today. Good luck to you. And make sure you go have a look at Fagradalsfjall, the recently formed shield volcano forming from a cinder cone in the past few months. It filled up the entire crater valley, and now it's a shield volcano instead of a cinder cone. Just fantastic. As some new real estate gets created in Iceland. Karimsky also on the list, explosive activity there, producing a 10,000-foot plume of volcanic ash. Great Sitkin, one of the Aleutian Island volcanoes now, having the aviation color code raised to orange, probably due to seismicity. Looks like there's some rising magma underneath the lava dome. Also, the lava dome has been expanding there at the Great Sitkin volcano in the Aleutian Islands. Fuego on Guatemala exploding, producing a 16,000-foot ash plume over Guatemala. Nevado del Ruiz exploding, 19,000-foot ash plume there over Colombia. Sangay in Ecuador, volcanic ash not observed. Don't assume it's not erupting. Revenador in the same country, 15,000-foot ash plume there as it explodes, producing a flight level 150 altitude ash plume over Ecuador. Sabancaya exploding, producing a 24,000-foot ash plume over Peru. And Nevados de Chilean erupting in central Chile there. No report on the volcanic ash plume size, if there is one. A great reminder to please not pole vault the caldera. Don't pole vault the caldera. Steve Stimpak didn't want kids pole vaulting the caldera. That's why you can't find any information about Steve Stimpak on the internet. He was trying to transition into table tennis stardom with the help of his Korean friend Yo So Dumb. Anyway, please do not pole vault the caldera. Please do visit our links below the video. Let's get back to the sun-facing suite of instruments on the GO 16. And here's this C-class flare. The peak flux from that C-class solar flare occurred at 0 dark 30. So 30 minutes after midnight universal time there was the peak flux of that C-class flare. No proton strikes. In fact, I don't even think there was a coronal mass ejection from it. All of the plasma stayed in the corona or somewhere thereabout. Here's the GOES magnetometer over the past 3 days. And we're seeing some spiky readings here. This is now going to smooth out because Earth is going to be in a South Pole current sheet if it's not already. Here's a visualization of that. You'll see the South Pole current sheet shown here in red. Expected to arrive today. Really, at any moment, it could suddenly snap across from the Earth's position in this North Pole current sheet shown here in green. And here's a line-of-sight view of the same data set. You can see the wild swings of that blue line there, an indication of which pole is in charge of the polarity of the current sheet in which the Earth is located. Great 3D representation of that. Next, the coronal hole line-of-sight plot showing the sun's B field in these blue lines here. You can see there is a coronal hole here rotating in on the east side of the sun. Right over here, you'll see that in red. That's South Pole oriented. And again, I would reiterate that the degradation of these sunspots has reduced the likelihood of solar flares along with the Earth-facing quiet effect. So when a sunspot moves into these areas right in here, it's less likely to produce major solar flares. because of the apparent emissivity of the material out of which the sun is comprised. We won't get into it in today's video, perhaps in a future cosmology segment. And looking at global geomagnetism, here is the KP index currently at 1. Geomagnetic chill conditions. And here's the real-time solar wind, which has got some serious errors probably in the data here, showing solar wind density dropping all the way down to 0.2 protons per cubic centimeter, solar wind speed dropping down to 245 kilometers per second. I find that highly dubious, and the ACE and Discover agree. You can see these orange and red error bars down here. That is likely bad data, as we don't see a shift in the phi angle or the BTBZ at that time. Unlikely for that data to be legit. And it's creating problems with the space weather modeling framework also. You see a great example of how it is a model and not raw data. Anyway, current conditions appear to be 3.76 protons per cubic centimeter for the solar wind density, so very low. Solar wind speed 357 kilometers per second, quite low there on the solar wind density and speed. So here's our geospace magnetosphere movie, and you're seeing this bad data reflected in the space weather modeling framework, a prime example of how garbage in, garbage out. If you have garbage data going in, your code can work just fine, but without the right data, your code is useless. Also, if your code is garbage, you can take good data and make a useless program out of that as well. That's 4 hours of data, probably not very accurate for the first 2. And here are ground magnetic perturbations, geospace delta B, and once again, the initial portion of this is probably completely inaccurate, as part of the space weather modeling framework's most important components include the solar wind speed and density. They're quite important, but that's the data that we have today. Once again, congratulations on realizing that our channel exists. Don't forget to press like and subscribe if you enjoy the content. Tell your friends and foes about the channel, as I think we need your assistance to get the videos out there. So thanks to everybody who shares the content on your social media, etc. Let us know in the comments what your favorite social media is. And visit our links and support the channel. Also, you may want to check out our Will Fauci Face Accountability or Do We Truly Live in a Banana Republic video. YouTube.com/smashamash/playlists. You'll be able to find that video. Because personally, I would prefer for frauds who are medical tyrants to face accountability. What say you? I know it's got nothing to do with space weather. We're also on BitChute, and there is an exclusive there for our 500 subscriber special if you haven't checked that out. That's what it looks like. Go have a look. We're also on Twitch. Thanks to our viewers on Twitch. And by the way, we will be streaming live for our meteorology segment today. We'll be taking a little break toward the end of our daily space weather video to live stream our meteorology segment. And here's our cosmology segment. This one's going to be pretty short. Some interesting stories regardless. Starting with noctilucent clouds and the aurora. So the astronomy picture of the day at apod.nasa.gov. You can look at it yourself at apod.nasa.gov, but here is the imagery, and what we're seeing here are aurorae. You can see some aurorae here, as well as some greenish aurora and some pink aurora there, showing different chemical components excited by charged particles there in the ionosphere, as well as the mesospheric clouds. You see these clouds right here? Those are noctilucent clouds. And if you think this is magma or something, it's sunlight shining under these clouds, as this is around the time of sunset. That's the astronomy picture of the day. Again, it's at apod.nasa.gov. Now, today we're not going to pick a random number at all. We're going to look at Cygnus X3. And you can look at the X-ray transients, if you like, from Cygnus X3. If you want to find it on the Neil Gehrels Swift-Bat X-ray Observatory, just hit find and type Sig space X-3. You'll find number 947. And it may be coming out of its quiescent state here. You can see over the last 30 days, it's remained in quite a quiescent state. Historically, over the last 16 years, that's way down here. It may be finally starting to come out of its quiescent state here as we see some additional signals there. A little bit higher voltage and, increased counts here. So that's 0.25. It's more of a more of a normal state here, and we would highly encourage radio astronomers to check out this object, especially when it transitions from an X-ray loud to an X-ray quiet state. Here's some imagery of it. It's associated with the star Deneb. Cygnus X3 is a small ultramassive companion orbiting this Wolf-Rayet star, and it has one of its jets oriented directly toward us. It's one of the only known cosmic ray point sources, and the brightest intrinsic object visible from planet Earth. Now, it's not going to show up in X-ray, but that is the Pan-STARRS optical survey. Here we'll give you a look at it in infrared on the 2-mass. There's the 2-mass imagery of Deneb, the tail of the swan in the constellation Cygnus. By the way, if you're wondering, it also has Göbekli Tepe oriented to it. And here we'll zoom into this on the DSS color survey. It's Deneb. And that's today's cosmology segment. We kept it brief and we integrated it into the daily space weather video. Please check out our other cosmology segments. You can find them all on our playlist, youtube.com/smashomash/playlists. Over 200 videos in the cosmology segments playlist. Let's check the electron environment. We don't see any charging hazards. Here's the 1-year chart of the electron flux from solon.info. And there is the 3-day chart from the GOES 16. I was wrong once again. We have not made it into warning territory. Don't be surprised to see us enter into warning territory, although it doesn't look like it's going to happen yet. NOAA not forecasting warning territory. NOAA forecasting flat levels here. The green boxes are the forecast. And I still say we're going to be a little bit higher than this, as there was an extended coronal hole wind stream of high-speed solar protons. Here's a diagram of the Earth's Van Allen belts. And now on to the total electron content forecast. By the way, the total electron content actually showing up in the news today. Anyway, here's the data which is likely to show you where GPS errors will occur. And GPS errors are most common around the equator at noontime. However, this gives you some additional data. It's a visualization of the electron density through the entire air column. Anyway, some anomalies here happening in the southern Atlantic Ocean once again. I'll let it play through a third time here. So some surprisingly high levels of electron flux here in the southern Atlantic Ocean. A little bit of chaos going on in the shape of Earth's Van Allen belts. Next, we're going to show you the Ionosphere layer, but first, an article here about the total electron content forecast and the total electron content showing up in meteorology data. So this article in the phys.org's Earth section about how a sudden stratospheric warming affected the northern hemisphere. And so the total electron content up there in the ionosphere and so on have an effect on the way plasma propagates into the lower portions of the atmosphere. And it's high levels of electron flux are essentially heating of that portion of the atmosphere. And feel free to pause the article here. We'll let it scroll back up again so you can read it if you like. Don't worry, it's the beauty of video on demand. Will be here when you unpause. So next, the ionosphere. We're going to show you just one slice of the atmosphere in visual data. The ionogram from Bureau of Meteorology of Australia. The Ionosphere located at about 300 kilometers altitude. Here is just one slice of the vibrational frequencies. And we're seeing extreme anomalies here once again. So some rapid frequency up and frequency down behavior happening here in both hemispheres, especially around this portion of the planet, especially between 90 and 45 degrees longitude. So a little bit of disorganization happening there in the ionosphere. This is actually one of the more anomalous data sets we've shown. And if you don't view the videos every day, you might not understand what I'm talking about. I can't really fully explain the anomalies here, but they are largely around North America, especially the northern part, and places like Western South America and the Central Pacific right here under my pointer. Anyway, here's the latest image coming through at 10:45 Universal Time. So we just did another fantastic meteorology segment. If you haven't checked that out, again, playlist, youtube.com/smashamash/playlist. Here come the rest of our bonus features. Here's the latest hydrogen alpha imagery from the ground-based observatory at Lurmouth, Australia, the National Sunspot Observatory System. You can see lots of filaments, lots of stuff going on here. Filaments, 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 prominences, prominences, prominences. Only 2 named regions. A bunch of activity kicking off down here where that solar flare came from. And more coming. So here's the latest intensitygram. We just pressed refresh there. Here's the latest magnetogram. So let's check out this sunspot. It's trying to become an alpha class sunspot. As these trailing umbrae are weak, it still does have the potential to produce C class flares. Here's this one. That is straight up alpha class. And there are the umbrae from that. So it looks like we're going to be down to 2 named groups here today, folks. And it's a weakening of solar activity. Here's the NASA GOES 16 SUVI map. And there are still a ton of filaments in between the sun and Earth here. The possibility for coronal mass ejections is still there. We're not going to put it up as a warning yet. We'll put it up as a minor watch. You can cite me as saying that there could be a coronal mass ejection, but I doubt it. It's actually more likely on the far side of the sun than on the Earth side of the sun today. And we'll close things out with one more animation of the closest star. So here's 94 angstroms from the Solar Dynamics Observatory. Great view of this C-class flare down here. We're going to zoom in on that. And 94 angstroms, like 131 angstroms, takes 10 minutes. 10 minutes, not 10 minutes, 10 images per minute instead of only 5 times as many images as the other wavelengths. And we were torn as to what imagery to show, so we just showed them both, 94 angstroms. And here's 171 angstroms and colorized magnetogram to close out the video. Thanks for tuning in. Remember to stare at the sun, use the proper instruments like our channel. Attempt to understand the physics. Don't drink, and if you do, don't drive. Seriously, don't drive. I might see you out there, and no matter how much I like you, I don't like traffic. Anyway, once again, welcome to the Neo Renaissance. Visit our links, support the channel. Thanks for tuning in, and may that solar wind be at your back.